Hello everyone, this video shows you how to use PIUAV for operation with GCPs. Firstly, open the data to be processed. This video uses demo data with GCPs. Open the image folder, we can see the image to be processed. Open the input folder, we can see the files, including can text shows the camera parameters. The CTL UTM-515-1N text shows the projection information of the image to be processed. The post-RTK text shows the location information file of the image. The project folder is used to save the new project. The GCP record file folder is used to save the GCP record of the image to be processed. Open the PIUAV software and click the New Project button on the main interface to open the project name dialog. And we can set the project name and the project path. The project can be saved under the per-build project folder. Then click Next to enter the Select Image dialog. Add the image to be processed in the image list. There are two buttons to add images. Add image, selecting the image through the pop-up dialog box, and add images to the list. Add image group, select the folder, and add the image under the folder. You can add multiple sets of images, but must be taken by the same camera. We clicked Add Image Group button, find the path of the image folder, and clicked OK to add the images under the Images folder to the list. Click Next to the Enter Image Position dialog. Click the Select button to select the project's coordinate system. Since the coordinate system of the image are known to be UTM-15N in the operation, we find the UTM-15-1N coordinate in the projection coordinate system and select it. Click the Import button to select the locational information file in text format of post-RTK text and assign each folder attribute value. Click Next to open the camera dialog. In this dialog, when you do not know the camera parameters, calibration, the coordinate system parameters default, and other parameters do not need to set directly to the next step. When you have the camera calibration parameter, input parameters, focal length, pixel size, principal of the points, position, distortion parameters in box, and then process the next step. So, we find the camera parameters in the CAM test and fill the information in the test document in the corresponding location of the camera dialog. Other parameters can be selected by default. Then click Next to open the product dialog. Post weight. The weight of posted data involved in Aerotriangulation. The option can be checked when the post precision is high. If the UAV with different GPS, post weight can be improved. For example, set to 10, used to control the accuracy of Aerotriangulation. Adjust color. Whether the final orthographic image file is automatically uniform color. Here we set the post weight to 10 and check the adjust color, then check Finish to finish a new project operation. The Project Setting button on the toolbar to reset the parameters of the current project. The Project Setting menu has two tabs to provide camera parameters and product parameters changes. Match images. It's the operation of extraction connection point between the images. According to the photo texture match and extract the connection point, we click the Match Image button and wait for the processing to complete. After processing is completed, Click OK. Click the Aerotriangulation button to perform an Aerotriangulation task and wait for processing to complete it. After processing is completed, click OK, and we can preview the result of Aerotriangulation in the project view. Double-click Aerotriangulation, open it in the view, process, and hold the right mouse button to rotate the image to preview the Aerotriangulation data, and slide to ruler to zoom in and out result. Click the Import Color Point button on the Control Point toolbar to import the Edit Color Point file. In the list of control points, select the control point to edit. Double-click will show all photos that exist. The control point of each image comes from the position of the center gradient in the corresponding photos in the GCP folder. Open Edit Picture, we can see that because the GCP is errored, the initial position of the control point is inaccurate. We need to move the control point markers of every image to ensure that the points of the control points are consistent with the accurate point positions. Click the Move Point button and move the red cross to the correct position, and then click the Modify Point on the toolbar button to modify the point. Then the point number and the crosshair are in the correct position. On behalf of the image, modification is complicated, and then modify the other images in turn to complete the editing of the control point. After editing all the control points, click on Absolute Orientation and GCP Adjustment in turn. We can view the processing time in the log output box. After GCP adjustment is completed, click the Terrain button to generate DSM. After all the process is completed, click OK. After generated DSM is completed, click the Mask button to generate the DOM. After process is completed, click OK. Double-click DOM, open it in the view, preview the DOM result, select the ruler, zoom in and zoom out the result, and support mouse dragging and pulling. Double-click the Hillshade to open it in the view. Preview the Hillshade data. Select the ruler, zoom in and out the result. Double-click Point Cloud to open it in the view. Press and hold the left mouse button to rotate to preview the point cloud data. Select the ruler, zoom in and out the result, and support mouse dragging.